In section 3.3, we're going to focus on dividing polynomials, as well as cover the remainder and factor theorems. We can use synthetic division to divide polynomials if the divisor is of the form x minus c, meaning a linear polynomial whose leading coefficient is 1. It's very important to keep in mind that synthetic division is specifically focused on this type of division, dividing by the form x minus c. So things like, x plus 2 would also work, because what you essentially have here would be like x minus a minus 2. So when you're dividing by linear factors, so things like x minus 3, x plus 2, anything that's of that form, where the leading coefficient of x is 1, is what we're going to be able to use synthetic division on. While it might seem limited in the scope of polynomial division, oftentimes this is still helpful, especially later on when we try to look for zeros or factors of a polynomial. Let's take a look at an example. We're going to compare two different methods of division. We're going to look at the general long polynomial division when we divide x cubed plus 4x squared minus 5x plus 5 by x minus 3. And we're also going to see what it would look like if we divide it using synthetic division. Again, we're able to do this because the divisor is of the form x minus c. For long division, the way that the long division process works is you write it like an old school division problem. The divisor goes on the outside, the dividend goes on the inside, and then what we do is you focus on leading terms. So the leading term of our divisor is x. You ask the question, what would we need to multiply by x in order to get x cubed? And the answer is it would be x squared. So the x squared is then going to go in your answer line, and it's going to go directly above the x squared column. So notice if you look at this column, anything that goes in this column will end up being of the form x squared. What we do next is then we take the x squared and you multiply it to the divisor. X squared times x would give us x cubed, like here. X squared times negative 3 will give us a negative 3x squared. And now what we're going to do, like you would in any standard division, is we now need to subtract this line. Okay. In order to subtract, it's best to change it to addition of the opposite. So I can make this a positive sign if I change the sign of everything on the inside. X cubed and what is a negative x cubed will cancel. A 4x squared and a positive 3x squared will give us 7x squared, which comes straight down. We bring down the next term in the polynomial, negative 5x, and we repeat this process. We once again ask, what do I need to multiply by the leading term here to get the leading term here of 7x squared? Well, 7x times x will give us 7x squared. So that comes up here in our quotient line. We then again distribute it to the divisor. 7x times x gives us 7x squared. 7x times negative 3 would be a negative 21x. We once again subtract this line. To subtract, we're going to change it to addition of the opposite, so plus, minus, plus. The 7x squared and the negative 7x squared cancel. A negative 5x and a positive 21x will give us a positive 16x. We repeat, what do we need to multiply x by in order to get 16x? Well, that answer is going to be 16. We do 16 times our divisor. 16 times x is 16x. 16 times negative 3 is negative 48. We again subtract that line. To subtract, change it to addition of the opposite. The 16x and the negative 16x cancel. 5 plus 48 will leave us with 53, which is the remainder. We know it's the remainder for a couple different reasons. First of all, x cannot divide into 53. Furthermore, we've already filled up the last line in our division. We already have a constant term here. So a lot of times the way you'll see us write it is like you would with an old school division. We can also write this as remainder over divisor. Okay. And so that's our answer. It's x squared plus 7x plus 16 plus 53 over x minus 3. If we wanted to instead do this with synthetic division, here's how it would look. In synthetic division, you take your linear polynomial that you're dividing by. Whatever's behind the x, change that sign to its opposite. If it's x minus 3, then it's going to be a positive 3 that goes in the block. And we're going to kind of block this off from everything else. Directly across from it, what we want to do is write the sequence of coefficients of our dividend. This was a 1x cubed, a 4x squared, a negative 5x, and a positive 5. So if you look at those sequence of numbers, sorry everybody, I'm not sure why it's jumping around here. Let's bring that back. That sequence of numbers, so this is a 1, 1, 4, negative 5, 5, we write across. And now what we do to start the synthetic division process is the first number comes immediately straight down. So the 1 comes straight down. Like this. And hold on one second. So we have our 1, 4, negative 5, and 5. We said that the first term comes straight down, so that's going to be a 1. What we do next is the number on the bottom row gets multiplied to the number on the block. 1 times 3 is 3, and that goes directly under the next number in your line here. So that goes right here. Once we have a number there, we add to go down. 4 plus 3 will give us 7. And we then repeat this process. The number on the bottom row gets multiplied to the number in the block. 7 times 3 is 21. That then goes here, and then we add to go down. Negative 5 plus 21 is 16. Take that 16, multiply it to what's in the block. We get 48. 5 plus 48 would give us 53. It will always be the case that the last value we get is going to be the remainder. So we have a remainder of 53, which we saw over here. And then the answer to this problem is these are the sequence of coefficients of our quotient polynomial. You can figure out what each coefficient goes with in terms of x term by realizing that if we start with a polynomial of degree 3 and we divide it by a linear polynomial, it will always end up producing a polynomial of degree 1 less. So that tells us that this is going to be a quadratic. The first term is the coefficient of x squared. The second term is the coefficient of x. The next term would be the constant term, and then what's left over would be our remainder. So it's a 1x squared plus 7x plus 16 plus 53 over divisor, which was x minus 3. Another way you can figure this out too is that after your remainder, the degree of the terms increase in order starting with a constant. So once you identify whatever your remainder is, the term directly to the left of it would be the constant, then the x to the first, x squared, x cubed, etc. terms. Let's get some practice. Let's use an example 5. They specifically say to do synthetic division on this. Let's actually do this one both ways. So I'm going to start off with the long division. I'm going to take x minus 2 and divide it into 2x squared plus x minus 10. To start off, we focus on the leading terms. What would we need to multiply by x in order to get 2x squared? Well, that's going to be a 2x. The 2x I write in the answer line directly above the x. That's our x column. We then take this and we're going to distribute it to the divisor. 2x times x would give us 2x squared. 2x times a negative 2 would give us a negative 4x. And now we need to subtract that line. In order to subtract, again, change it to addition of the opposite by changing all those signs. 2x squared and negative 2x squared cancel. A positive x and a positive 4x would give us positive 5x. And we now repeat. What would we need to multiply by x in order to get 5x? Well, that would be a positive 5. Positive 5 is a constant, so notice that it goes directly above the constant line in our work. We then take that positive 5 and distribute it to the divisor. 5 times x is 5x, and I forgot to bring the next term down. So whenever you go to the next line, always bring the next term down. That negative 10 should have came down. 5 times x we said was 5x. 5 times negative 2 will give us negative 10. And again, we're now going to subtract the line. To do that subtraction, let's change it to addition of the opposite. 5x and negative 5x cancel. Negative 10 and positive 10 cancel. And so we get a remainder of 0, which means that it actually divides in evenly. So the answer is 2x plus 5. Let's do the same process, but let's do it with synthetic division. With synthetic division, we start by putting a number in the block. It's always the exact opposite of what you see behind an x. So if this is a negative 2, then a positive 2 has to go in the block. Directly to the right of it, we write the sequence of coefficients of our dividend. That is 2, 1, and negative 10. To start the synthetic division process, it's always the case that the first number comes straight down. So we have a 2 coming down. What we then do next is, remember, the numbers on the bottom multiply to the number in the block. So bottom times block. 2 times 2 gives us 4, and that goes directly under our next column. Can you add to go down? 1 plus 4 would give us 5. And then once again, numbers on the bottom times numbers in the block. 5 times 2 gives us 10. We add those to go down. Negative 10 plus 10 is 0. That was the last column entry, so that was our remainder. So again, it shows a remainder of 0. It divides in evenly. And the coefficients here would be that of a constant and an x to the first power term. So the answer is 2x plus 5. Can you get the same answer either way you do it? But one of the things that synthetic division will do for you when you divide by this kind of a term is that it kind of declutters it a little bit. It's a little bit less writing and perhaps a little bit less sign usage. Let's take a look at the next one. This is yet one again that I will show you with both methods how to do it. Let's start with long division first. So we want to take x plus 2 and we want to divide it into this cubic polynomial. This, what you're about to see, is not only true for long division, but will also be true for synthetic division in a moment. When we write out the terms here, it's very important that every power of x, starting from the highest power all the way down to the coefficient, to the constant coefficient, is shown. Notice that there is no x squared term here. So what we can do is we can actually put it in as a placeholder. That means that there were 0 x squareds. So I'm going to put a 0 x squared term in, because that's going to help to keep everything nice and orderly. And now we go ahead and we begin. Focus on the leading terms. What would you need to multiply by x in order to get 5x cubed? Well, that would be a 5x squared. So that goes above our x squared column like this. We then distribute. 5x squared times x would give us 5x cubed. 5x squared times a positive 2 would give us a positive 10x squared. To subtract, let's change it to addition of the opposite. 5x cubed and negative 5x cubed cancel. 0x squared and a negative 10x squared will give us a negative 10x squared. Let's go ahead and bring the next term down and repeat. What do we need to multiply by x in order to get a negative 10x squared? Well, that would be a negative 10x. So that goes up top. We then distribute it to the divisor. Negative 10x times x is negative 10x squared. Negative 10x times a positive 2 would be a negative 20x. We're now going to subtract. Let's change that to addition of the opposite. Negative 10x squared and positive 10x squared cancel. 6x and 20x would add to give us 26x. Bring down the next term of plus 8, and we repeat. What do we need to multiply by x to get 26x? Well, that's going to be a positive 26. 26 times x is 26x. 26 times 2 is 52. We now go ahead and subtract. To subtract, change it to addition of the opposite. (26x) and negative 26x cancel. A positive 8 and a negative 52 should give us a negative 44. And that's going to be our remainder. So our final answer, the quotient is 5x squared minus 10x plus 26. And then we can do plus remainder over divisor. Let's do the same problem, but let's now do it with synthetic division. To begin, I'm going to write a block and a bar across the bottom. Remember, the number that goes in the block is the opposite of the value you see with the x. So if that's a plus 2, I'm going to put a negative 2 here. The next thing we need to do, this is important, you need to put the sequence of coefficients of your dividend, starting from the highest power, which would be the 5x cubed. Remember, there is no x squared term here. So we need to put a coefficient of 0 to represent the x squared column. Then we have a 6 for the x, and then lastly an 8 for our constant. Now that it's set up, we're going to begin synthetic division. The first number always comes straight down to get started. So 5 comes down to the bottom. Numbers on the bottom get multiplied to the number in the block. 5 times negative 10, 5 times negative 2 is negative 10. We then add to go down. We get negative 10. Bottom times block, negative 10 times negative 2 will give us positive 20. Add to go down. That's going to be 26. Bottom times block would give us negative 52. Add to go down, we get negative 44, which is our remainder. Again, working backwards, what's beside the remainder is the constant, then the x squared term. So the solution is 5x squared minus 10x plus 26 plus negative 44 over divisor, remainder over divisor. That's going to be x plus 2. One of the things that's going to be useful to us that will also help to determine remainders is something called the remainder theorem. If the polynomial f of x is divided by x minus c, then the remainder is f of c. What this oftentimes can do for us is give us a roundabout way to calculate some of these values. For example, instead of finding f of 2, if we just do the polynomial division by x minus c, that remainder will give us the value for f of c. So for instance, in example 7, they ask us to use the remainder theorem to find f of 2. According to f of 2, this is going to be the remainder when we take x cubed minus 4x squared plus 5x plus 3, and when we divide it by x minus 2. That we can do very easy computationally by using synthetic division. We're dividing by x minus 2, so a 2 goes in the block. The sequence of coefficients is 1, negative 4, 5, and 3. Let's do the synthetic division. 1 comes down. Bottom times block gives us 2. Add to go down, negative 2. Negative 2 times positive 2 would be a negative 4. Add to go down. Bottom times block would give us 2. Add to go down would give us 5. So the remainder for this one is the value 5. And according to the remainder theorem, if we were to take this polynomial and evaluate it at 2, the answer is going to be equal to 5. So it's worth asking, what's the big deal here? We know how to do function evaluations. Well, the reason why this is so important or helpful to us is if you think about what it would involve if you had to actually evaluate the function f at 2. It involves cubic powers, squarings, a lot of multiplications, additions, and subtractions. Whereas if we use the remainder theorem, all we had was really just a bunch of basic multiplications and additions. So computationally, the complexity is much, much easier via using the remainder theorem. Okay? If you're curious or if you're a little bit suspect of this, trust me, it does work. You could check it if you're curious, but let's plug it in. F of 2 is equal to, again, this is the whole goal, is that you don't want to do this, okay? But just so you believe this, let's actually plug it in and check this one. We know the answer is going to be 5. Let's see how that would work out. 2 cubed is 8. 2 squared here is 4. And then 4 times 4 would be 16. That's what, 10 plus 3. 8 minus 16 is negative 8 plus 10 plus 3. Negative 8 plus 10 would give us 2. And of course, 2 plus 3 does give us 5. So it does work, and it's kind of a nice way to do some function evaluations if you have perhaps polynomials that are large in order. So again, what does the remainder theorem say? If you take the polynomial f of x, when it's divided by x minus c, the remainder you get from that polynomial division is equal to the function f evaluated at the value c. And this value c, by the way, is the same number that you would have when you're plugging it into your block in the synthetic division. Let's take a look at another one of these. Let's suppose we're given the polynomial 3x cubed plus 4x squared minus 5x plus 3. We want to use the remainder theorem to find the value f of negative 4. So I'm going to put negative 4 in the block. We have 3, 4, negative 5, and positive 3. Let's do the synthetic division. The first number comes straight down. Bottom times block, negative 12. Add to go down, negative 8. Bottom times block would be 32. Add to go down, that would be positive 27. Bottom times block, that would give us negative 108. Yep. And then add to go down, that would give us negative 105. So when we divide this polynomial by, essentially you'd be dividing by, remember, it's x minus c. So the division would have been by x minus a negative 4, which is x plus 4. Remember, it's the opposite of what's behind x, is what goes in the block. We get a remainder of negative 105. And according to the remainder theorem, that's equal to the function evaluated at c. So f of negative 4 should have the value negative 105.